Connecting the street neutral and the generator neutral at the transfer switch presents no issues. The vast majority of transfer switches are designed to maintain a continuous neutral connection. The neutral is a grounded conductor that provides a return path for current. In a properly wired system, the neutral carries unbalanced current, which is the difference between the current flowing through the hot conductors. When a generator is connected to a house through a transfer switch with a shared neutral, the generator's neutral is effectively connected to the utility's neutral. This connection is necessary for proper operation of many appliances and electrical devices that rely on a stable neutral reference. The grounding system, which includes the neutral conductor bonded to ground at the service entrance, ensures that fault currents can safely return to the source, tripping circuit breakers or fuses and preventing electrical shock hazards. Separating the neutral conductors between the utility and the generator would create a floating neutral condition when the generator is running. A floating neutral can lead to erratic voltages and potential damage to sensitive electronic equipment. With a floating neutral, the voltage on different circuits can fluctuate significantly, exceeding the rated voltage of the devices connected to those circuits. This can cause overheating, malfunction, or even complete failure of the equipment. The National Electrical Code, or NEC, addresses grounding and bonding requirements to ensure electrical safety and proper operation of electrical systems. Section 250.24 specifies that for alternating current systems, the grounded conductor, typically the neutral, shall be connected to a grounding electrode system. This connection establishes a low impedance path for fault currents, facilitating the operation of overcurrent protective devices. Section 250.30 outlines the grounding requirements for separately derived systems such as generators. It specifies that a grounding electrode conductor must connect the generator's frame to a grounding electrode. This connection ensures that the generator's frame is at ground potential, preventing shock hazards and providing a path for fault currents. The NEC also requires that the neutral conductor be bonded to the generator frame. This bonding ensures that the neutral and the grounding system are at the same potential, minimizing voltage differences and providing a stable reference for electrical devices. When a transfer switch is used, it typically switches the hot conductors but not the neutral. This means that the neutral conductor remains continuously connected to the grounding electrode system, whether the power source is the utility or the generator. This continuous neutral connection is essential for maintaining a safe and reliable electrical system. Regular generator maintenance, including running the generator under a load, is crucial for ensuring its proper operation and longevity. Running the generator under load helps to burn off any accumulated fuel deposits, lubricates the engine components, and verifies that the generator can deliver its rated power output. The frequency and duration of these maintenance runs depend on the generator's manufacturer's recommendations. However, a common practice is to run the generator under at least 50% of its rated load for about 30 minutes to an hour every month. During the maintenance run, it's important to monitor the generator's performance, checking for any unusual noises, vibrations, or exhaust fumes. The voltage and frequency should also be checked to ensure they are within the specified ranges. If any problems are detected, the generator should be inspected and repaired by a qualified technician. It's also important to keep the generator clean and free of debris. The air filter should be cleaned or replaced regularly to ensure proper airflow and prevent overheating. Fuel and oil levels should also be checked and replenished as needed. Proper maintenance not only extends the life of the generator but also ensures that it will be ready to provide power when it's needed most. The transfer switch plays a crucial role in safely switching between the utility power and the generator power. The transfer switch prevents backfeeding, which is the flow of power from the generator back into the utility grid. Backfeeding can be dangerous because it can energize the utility lines, posing a risk to utility workers and the public. Transfer switches are available in two main types: manual and automatic. A manual transfer switch requires the user to manually switch between the utility power and the generator power. This type of switch is typically less expensive than an automatic transfer switch, but it requires the user to be present to operate it. An automatic transfer switch automatically switches between the utility power and the generator power when it detects a power outage. This type of switch is more convenient than a manual transfer switch, but it's also more expensive. Regardless of the type of transfer switch used, it's important to ensure that it's properly installed and maintained. The transfer switch should be installed by a qualified electrician in accordance with the NEC and local electrical codes. The transfer switch should also be inspected regularly to ensure that it's functioning properly. The installation of a standby generator and transfer switch involves several steps. Firstly, a suitable location for the generator needs to be selected. The location should be well ventilated, protected from the elements, and easily accessible for maintenance. The generator should also be located away from any flammable materials. Secondly, the electrical wiring needs to be installed to connect the generator to the transfer switch and the house's electrical panel. This wiring should be sized appropriately for the generator's output and should comply with the NEC and local electrical codes. Thirdly, the transfer switch needs to be installed between the utility meter and the house's electrical panel. The transfer switch should be rated for the maximum current that the house's electrical panel can handle. Fourthly, the grounding system needs to be properly installed. This includes connecting the generator's frame to a grounding electrode and bonding the neutral conductor to the generator frame. Fifthly, the generator needs to be connected to a fuel source such as natural gas or propane. The fuel line should be installed by a qualified plumber in accordance with local plumbing codes. Sixthly, the generator needs to be tested to ensure that it's functioning properly. This includes running the generator under load and verifying that it can deliver its rated power output. Safety is paramount when working with electrical systems. Firstly, always disconnect the power before working on any electrical wiring. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear safety glasses to protect your eyes from flying debris. Fourthly, follow the NEC and local electrical codes. Fifthly, if you're not comfortable working with electrical systems, hire a qualified electrician. The NEC provides detailed requirements for electrical installations, including those involving generators and transfer switches. Firstly, Article 700 covers emergency systems, which are electrical systems designed to provide power during a power outage. Secondly, Article 701 covers legally required standby systems, which are electrical systems required by law to provide power during a power outage. Thirdly, Article 702 covers optional standby systems, which are electrical systems that provide power during a power outage but are not required by law. These articles address various aspects of generator installations, including wiring methods, overcurrent protection, grounding, and transfer switch requirements. In addition to the NEC, local electrical codes may also have specific requirements for generator installations. These codes may vary depending on the location and may address issues such as noise levels, emissions, and setbacks from property lines. It's important to consult with the local building department to determine the applicable codes and regulations before installing a generator. Understanding the principles of electrical grounding and bonding is essential for ensuring electrical safety and proper operation of electrical systems. Firstly, grounding refers to connecting a conductive object to the earth, providing a low impedance path for fault currents. Secondly, bonding refers to connecting two or more conductive objects together, creating an electrically conductive path between them. The purpose of grounding is to prevent electrical shock hazards by ensuring that the voltage of conductive objects remains close to ground potential. The purpose of bonding is to minimize voltage differences between conductive objects, preventing the flow of current between them and reducing the risk of electrical shock. In a typical electrical system, the neutral conductor is grounded at the service entrance, and all metal enclosures, such as electrical panels, conduit, and equipment housings, are bonded together. This creates a comprehensive grounding and bonding system that provides a safe and reliable path for fault currents. When a fault occurs, such as a short circuit between a hot conductor and a metal enclosure, the fault current flows through the grounding and bonding system back to the source, tripping a circuit breaker or fuse and disconnecting the power. Without a proper grounding and bonding system, the fault current could flow through a person who comes into contact with the energized metal enclosure, resulting in a severe electrical shock. Therefore, it's crucial to ensure that the grounding and bonding system is properly installed and maintained. In summary, connecting the stream neutral and the generator neutral at the transfer switch is a standard practice that does not cause harm. This connection is necessary for proper operation of many appliances and electrical devices that rely on a stable neutral reference. Regular generator maintenance, including running the generator under load, is crucial for ensuring its proper operation and longevity. The transfer switch plays a crucial role in safely switching between the utility power and the generator power, preventing backfeeding and ensuring a continuous neutral connection. Proper grounding and bonding are essential for electrical safety and proper operation of electrical systems. By following the NEC and local electrical codes and consulting with qualified professionals, you can ensure that your generator installation is safe, reliable, and compliant with all applicable regulations.